Okay. Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, January 24th. We are going to get started here in a moment with the agenda. But first, we actually have a not new to the community, just maybe new to the community call member here. So, Andre, go ahead and take it away if you want to give us a little introduction into what you do and what brought you to wasmCloud. Love to hear that kind of stuff.
Hey, so my name is Ondra. I'm from Prague, Czech Republic, Central Europe. Uh, I've been programming for like 10 years professionally. I studied computer science in Prague, and like I started with Go for my bachelor thesis, and I stayed with it like ever since. So that was shortly after Go 1 was released, I think. And yeah, I mostly worked in like startups. I did some data processing on Apache Kafka, did some microservices over gRPC. Actually, then I tried to work in sort of more of a corporate environment. Reached very close to burnout there, so I had a break from IT then for like maybe 2 years, and I came back like recently. So basically, I'm in the phase that I'm like researching what cool stuff is new on the internet after this break. So that's how I stumbled over wasmCloud, I think. And yeah, so checking all the new stuff and like reading on domain-driven design, event sourcing, XOR model, and whatnot. So yeah, in the research phase, not really implementing anything right now. So I think that's about it. And I'll hand it back to you,
Sounds great.
Brooks.
Well, thank you so much for the introduction and apologies for getting the wrong pronunciation on your name.
No
I know
problem.
that I know that we've been talking in Slack pretty often about you've been picking up Rust a little bit more, looking into our Go provider SDK. So as you keep experimenting there, maybe we can bring that up in the community meeting.
Sure.
All right, folks. Well, without further ado, I think we can go ahead and get started. We've got a little demo. It is a terminal only demo, but it should be kind of fun for today. It's really I'm not downplaying it a lot. It is a very short terminal demo, but it is fun to see it work, and you can try it too. Um, and then we'll get into kind of a short discussion on OTel metrics. We made a little bit of progress in that area, and I'm not quite at a point yet where I can show you any more work around what we've instrumented, but I'd love to talk about what we're thinking about, and then go a little into the roadmap update. We've had a couple things move statuses, but really specifically, we're about to close out a lot of our previous RFCs in favor of a new one that should be coming soon. So, let me go ahead and start with an introduction into this new cool thing that we're talking about called WRPC. Now, this is it's not early stage in terms of thought, but it's early stage in terms of getting this implemented in terms of wasmCloud. And this all stemmed out of a draft RFC that Roman wrote up and proposed. I don't know. Oh, hey, wait, no, that wasn't that long ago. A little while ago. So this is a more new RFC, but we've been thinking about a way to do this for a long time and working on the design of it. And WRPC is going to be the name of the protocol, what we're calling this functionality. So to give you a TLDR, as we're pushing wasmCloud to 1.0, now is kind of the time to be looking at the underlying protocols and things that we want to promise stability of going forward. And we've done that kind of thing for our wasmCloud control interface. I've talked about that RFC in a previous meeting, so I don't need to bring it up here. This is a similar approach where we're looking at the way fundamentally that WebAssembly components or actor modules or capability providers communicate over NATs. So communicate over the RPC layer in wasmCloud. And if you needed I'll pull up a diagram or two here in a second. But really actually, why don't I do it now? The TLDR of this whole thing is that right now, when we are running wasmCloud Actor, you run an Actor component, you'll notice that in all of the examples where I demoed Rust, TinyGo, JavaScript or TypeScript and Python components, we're doing this first section here. Or we're doing a diagram like this, where a wasmCloud HTTP server capability provider sends an HTTP request that comes in over the wasmCloud contract, wasmCloud HTTP server, and the operation HTTP server dot handle request. Now we do something inside of the wasmCloud host here that we're calling a wasfill, and we do it for a couple of different things. But in this example, we take that incoming request and we turn it into the valid invocation of a component's WASI HTTP incoming handler request function. So right now, this wasfill is essentially that translation between wasmCloud contract to WebAssembly or to WASI interface, WASI interface. And this is because before this even existed, essentially this is the way that wasmCloud would communicate with an actor module. So we would use the wasmbus protocol, which is low level, but we've been effectively using it as a way to communicate between wasm guest and wasmCloud host for the last 4 years since the project started. And now that we're in the component world, we both have a new way of interacting with components with strongly typed complex data types, which is the component model. And we have these higher level contracts for application development. Now, WASI HTTP is one example, and it's arguably one of the simpler ones because it's like handle this request or make this request. And there's going to be additional contracts that we move over from something like wasmCloud HTTP server to something like something like wasmCloud key value into something like WASI key value. And you can kind of generally track the broader point there with the wasmCloud proposal. But the difference is, instead of our RPC having this wasfill layer, we are going to emphasize direct communication over WebAssembly components, imports, and exports. And the way that we want this to feel is like composing components over a distributed network. And distributed components is something that's explicitly out of scope for the component model. You can take a look at one of the keynote talks, I think, from last WASM Day from Luke Wagner, where he talked about that. This is what it's like to compose a component using like the WASM tools compose tooling. So you have maybe two different components, whatever source language, doesn't matter. One of them has an import and the other one has an export, and you can compose them together essentially at compile time to create one composed WebAssembly component. And so when you call that import or export, you're calling the other component. Now this works really, really well for kind of composing those components at build time for functionality that you want to be kind of built into your one component, but it doesn't work for the distributed use case. And we've kind of been getting around that with, like I said, wasifills. But this is what we want. And I could not resist putting in this meme after I trying to think about it this morning. This is what WRPC will be like when you use wasmCloud. So instead of directly linking those imports and exports together at compile time, you can link those imports and exports together at runtime over a distributed network. And that lets you distribute components on any set of infrastructure, running some in the cloud, some on the edge, some on your laptop, and link it with a component over the NATS lattice. And that lets you do things like run appropriate workloads on like machine learning workloads on a machine where a GPU is running. We're doing lightweight inference at the edge. It enables you to automatically scale these components independently of each other, but still communicate using the same notion without joining those together. And essentially allows this component model thinking of composing components to overtake what we've been doing for a long time with wasmCloud specific contracts and the RPC layer that we have. So specifically, when you link to a number of components with WRPC, links are going to be unidirectional. So they're going to follow, they're going to essentially link together and import and export, but it's going to be directional. And then it's also going to be based on the specific WASI package and interface that you're using. So you will link an HTTP server capability provider or just provider component to an actor component like your KV counter, what have you. But this is directional, like you have a targeted direction that you're going to be basically the source and the target of the invocation. So this RFC, where is it? This RFC is all around is primarily around the proposal of the WRPC protocol. And there are really specific details in here of how we're going to be encoding information, like sending back results or errors, how it's designed in a way such that it can be implemented with NATS or it could be implemented with HTTP, which provides us a lot of flexibility around invoking specific component handlers. And what you all may find the most useful is this section under function invocation, where it can be a little bit easier to see how we're going to do this. So instead of an actor listening on like actor ID dot lattice ID or wasmbus.rpc dot actor ID dot lattice ID, which is what we do now, it will listen on something like actor ID and then protocol information dot WASI HTTP outgoing handler. So it's a lot of information. I would recommend taking a look at this RFC if you're interested in some of the lower level details of how we're going to make this work kind of at the binary protocol level. There is going to be another RFC that comes out pretty soon around what this means for changes to the wasmCloud linking model and how we're going to change like what topics we're going to subscribe on. But that will be coming soon, and we'll propose that for community feedback as soon as I can finish filling out the form and all of that. So I have a little bit of a demo I wanted to show you through. I didn't ask Roman if it was okay for me to show this, but I think he's appropriately prefixed it with like, hey, this is an example to show how this may work. But I can show you what this looks like, but I do see some thinking in the chat. So let me take a look there. So Vance, your comment was the first one I saw, and then so I might need a little more context for yours. So when I'm saying that Vance, your question was compile time of what? Can I only, yeah, feel free to elaborate. I don't know.
It seems to be resolved. I had a concern about what I was hearing, but I think Kevin has allayed my concerns, so never mind.
Okay. All right. So let's see, moving on from that, Marcelo, your question is around intercepting and monitoring extensions for the HTTP requests and responses. Do you mind adding in a little bit more context there about what you mean?
Yes, if I can use, for instance, an API gateway or something like that, but can I use this one or is it possible?
Yeah, I think I think that that might be a little better covered in the other RFC that's going to be coming with here shortly. But when it comes to like using these standard sets of capabilities for like HTTP request and response, I think we'll even have a better story about being able to use it for tools like a proxy or an API gateway.
Okay, thanks.
Yeah. Okay. Well, let me show you a little bit. First, why don't I show you some of the code? I'm not going to walk through the implementation, but I want to show you what this would look like. So one of these, I believe it is this one. This is an example of a component that is generating it is generating types and bindings from an example custom WIT interface. So this is something that's not a WASI interface. It's not a wasmCloud interface. This is something that like you as a developer would define when you have your own protocol that you want to, you want to invoke another actor, like an actor to actor call. This is what it may look like. So we have a implementation of this guest export. And then you're simply able to call functions and methods on different WebAssembly components here in the code. So the point of showing you this example is that all of those details around the binary encoding and what topics it's going to listen on and all of those things are going to be done for you at the wasmCloud level, same way as they work essentially today, where we're setting up subscriptions and dealing with that NATS, that seamless distributed networking that we know and love so well. Now I'm going to go ahead and set up based on the README. I'm going to go ahead and set up this little example, and you all should see a terminal now. So what I'm going to do is look nice and hackery by pulling up a bunch of different things. So we will go ahead and run NATS in the background, and then we'll run our, we'll run our example foobar. Oh no, not updated for us since the last time I did this. Okay, we'll see how this goes. If I start cutting out, then let me know. Everything is getting a little slow, so we'll see. We're essentially going to be using this example test WRPC server. We're going to be running 3 different WebAssembly components, and they are going to be setting up subscriptions based on the WIT that's embedded in each of those components. And then what we can do is subscribe on NATS or subscribe on just kind of all NATS topics to take a look at what traffic is flowing. And last but not least, we can make a request to invoke that WebAssembly component, that example run that I just showed. And we can actually do that directly over NATS at a specific endpoint. This is one of and I will continue to buy myself time as this Rust builds. This is one of the things that I love the most about this RPC protocol. The previous way that we would invoke an actor components handler directly was essentially by making a NATS request on wasmbus.rpc.actorID normally it's default, but the lattice name. And then what we would have to do is pass an invocation struct with all of the right fields and all of the right information to be able to invoke that actor component. And nothing changes there. We still have to pass all of the right information. But what is really neat is something that you had to specify before when using wash call is the is like the operation name. And that was something that you normally have to dig in the code to find. But now you are able to see what package and what interface and at what version and what function you're invoking directly on the command line. So this should be really nice. I don't expect for the normal actor component workflow to consist of doing NATS calls like this. But what it does let us do is really augment the flow for wash call. So we can provide a much better experience, especially for contracts that we know about, like WASI HTTP, for like invoking this component quickly. Nice. All right, everything built. I bought myself enough time. This is normal. Don't worry about that. So now I'm subscribing on all, I'll embiggen this a little bit, subscribing on all of the NAS traffic. I can make a request on run, which it doesn't return anything. It was just invoking all of the components. But what you can see in the flow here is making the request to that first WebAssembly component. And then from there, we get a unique inbox generated for the response. And then from there, some other aspect here is, that one run example invoking the foo component, and then the foo component invoking the foo bar component. And all of these inboxes you'll see kind of flow down in a sequence, including a content range, which specifies exactly how many bytes we're going to be transferring. But what's really important here is that these components are able to communicate over these specific function topics, and it's not something that you need to specify in the code. And this actually does have preliminary support for WebAssembly component resources and manipulating them using an inbox. So if you have a resource, you can pass an inbox to the caller of the function, and they can actually call functions and methods on that resource, still living on the source component of the invocation. I'm hopefully using all the right words there. And sorry, I kind of just felt like I needed to sneeze. But I'm looking forward to showing a little bit more of the POC here. I just wanted to show like kind of the initial workings of this because it'll be cool to talk about it as this evolves. So that was a lot of information, and I'd like to, I think that is essentially what I had planned to show for the demo, for like this initial look at the protocol. Do folks have any questions or comments? Happy to talk a little more here. Oh, sorry, Kevin. I was sending something in chat. Go ahead.
Yeah, I had a question that I asked on the RFC. I could just be reading the subject composition stuff wrong, but if you have the same actor deployed in two different lattices, it doesn't look like the topic differentiates between those. So it looks like it would go to the RPC call would go to the actor in both places. Is that intentional, or am I reading it wrong?
It is we do have the ability to do that, but you're reading it correctly. So I'll just restate from the beginning. So the intent behind this protocol and like this definition is to show some level of flexibility around not specifically needing to be implemented over NATS or HTTP, but it also shows flexibility around not needing to be wasmCloud specific. And what is not immediately
Prefix.
what's not immediately obvious, I think, here is this prefix. So the prefix is optional, but in the wasmCloud context, the way it's somewhat represented here, but the way that I see us doing this is an actor would listen on lattice name dot unique identifier dot WRPC, for example. So we would preserve the same level of multi-tenant isolation that we have today by specifying the lattice and the ID in the topic. Does that answer your question, Kevin? And do you feel like that?
Yeah, that's great.
Cool. There'll be some more details about how we can use that prefix in so interesting ways in the following RFC, but I will punt on that one until then, because we can talk about that one. Other questions? Yeah, Vance.
So I just have an idea that I'm trying to understand whether it makes any sense or not. But I think about this composition and what the component model offers is really exciting. And then wasmCloud adds distribution, as you say, that isn't baked into the component model. So the wasmCloud's there to solve that problem. And as I'm understanding it, though, what we continue to do with this new RFC as well as the existing is that you compile in the RPC protocol to your component, right? And is there not a future where we could have that like wasmCloud specific shim be a component that can be composed together to make these components independent of that? Does that make any sense?
That does make sense. Yeah. And I want to be specific that with all of this, you will not be compiling in any of the RPC logic or wasmCloud specific bits into your component. The way that it will work is the wasmCloud host itself is going to take a look at your imports and exports and then set up the NAT subscriptions and like appropriate communication layer there, so that from the component perspective, you're just communicating over the import and export handlers that you define. Same thing on the receiving end. It's just the interconnected tissue is facilitated by wasmCloud and then over NATs. But to your point, the component that implements that is basically the wasmCloud host right now. And and in a world, in a maybe parallel world, but could be completely done, is that logic is specifically a component that implements that logic where, for an import and an export, you pull it in and then you publish the request or make the request over NATs. Does that make sense and address kind of what you're thinking there, Vance?
Well, I think so. But so what you're saying is that my view isn't incorrect, that the way it works today and what might be possible, but that is the way it works today, right? You just showed us a component, an actor, and that actor was importing the WRPC, right? So that's then compiled into that actor, right?
That specific example, like the WRPC one, is just an illustration of a custom contract. So what that would look like is like in the regular component world, you would just build using the standard interfaces. But the example that I just showed is a specifically designed contract just to show it off.
Okay.
But you won't need to import that.
Oh, okay. So I'm sorry if I haven't tried using the new WIT stuff myself yet, although I will have to very soon. So you're saying that don't have to pull in RPC.
Correct.
Oh, okay, great. Excellent.
Yeah, it is just as important as it is for us to make this work. It's important that you don't need to build in that platform specific stuff into your app, like platform being wasmCloud. And you could bring something that works already with WASI HTTP and it works out of the box, distributed.
If I can have a second part to my question, I guess back to the question I raised in the chat. I keep hearing everyone characterize this as this composition as a compile time operation. Is there not an opportunity for runtime integration of these components?
I think
Either in the component model at large or in the wasmCloud context.
right now, Taylor, if you raise your hand to specifically address that, you go ahead. But I was going to give it my shot.
You can keep going if you want, or I can. I don't care.
Okay, do it, and then I'll see if my understanding matches up.
Yeah. So you can compose and compile. It's post compile time right now, but still static is what I would describe it as. So that's the normal component tooling. So you have your component A and component B, and you want to put them together, and you basically do like wasm tools compose, or you can do it in code dynamically at the time you have to compose them together statically. wasmCloud lets you do it dynamically right now over the lattice. And that's actually the whole goal of what Brix has been showing off, is to have that dynamic part of it so that you can just say, here's this one thing, and now it's put together, it's linked together. And then I can swap it out or move different components. There is a future as well, though they haven't gone down that path all the way yet, though they want to, is to support the like dynamic switching out of components like during like execution, or basically dynamic linking of them. Right now they're static linking, but it's done post compilation. So it was like what Kevin said in chat earlier, where you're defining the you don't need the source code, you just need the two components, and then you can see their interfaces and then put them together.
Excellent. And just to be clear, wasm tools, is that what you said? Is coming from the Bytecode Alliance, is it? Yeah. Okay. Thank you.
Yep, wasm tools is from the Bytecode Alliance, and if you wanted to look specifically at that one command, it is well, I guess it's wasm tools compose, but wasm compose is the one. I am planning on doing like a blog post on this, so I will compare like the wasm tools compose and then the wasmCloud part. Yeah, Kevin, you've thanks for had your hand up for a little bit. Thanks for the patience.
Yeah, just have a quick question on the encoding stuff for WRPC. So looking at the RFC, there's like a very well named spec for the binary encoding. Is it possible to compile the binary encoder to WASM as well, so that people in other languages don't have to rewrite their own implementation of Woob or Wooby? I don't know how to pronounce it.
Yeah, Wooby or
Wooby. That's
Woob cuddle, whatever. You like Wooby? All right. Wooby is good. I don't see why not. I mean, this feels like a very, like, we're not reaching out to the network. We're not, doing things with sockets or file handlers or anything. It just feels kind of like logic.
Yeah, wasn't sure if there's like a catch-22 or chicken and egg type problem where you're trying to encode something using that by talking to the .wasm for the encoder, and then how do you? Yeah, I'm not sure how that works, but in short, it would be cool if we didn't have to rewrite that stuff for every different language that we want to use.
Yeah, Yeah, it's a great point. I I can't promise that. Well, I didn't write any of this, but I'll pick Roman's brain a little bit on that. Knowing Roman, I'm sure he has a way to turn this all into WASM at the end of the day, which would be cool. All right, folks, other questions? All right. Well, I think we can go ahead and move on to the rest of the meeting, but thank you all so much for taking a look at an early look at a very cool evolution in the wasmCloud RPC protocol. Just like language support and other things related to components, we will be continuously tracking this as we move forward, and we'll talk a little bit about it in the roadmap update as well. Before we get ahead of ourselves, though, we will talk. I put this placeholder here, and I will be completely honest. I hope to be a little bit further along with things that I wanted to talk about with respect to OTel metrics. This is on the roadmap for 1.0. It just hasn't had any movement since we talked last, which honestly may have been, well, maybe I just mentioned it a little bit like the week before. But for anyone who is not aware, who hasn't been on the community call or looked into wasmCloud too deep, we support OpenTelemetry trace exporting today. We've had that feature for a long time where when you run a wasmCloud runtime, you can provide an OTLP exporter URL, and we will export traces no matter where your individual hosts or components are running to the tracing exporter. And what we actually do special there is encode the trace header over NATs. So even if you make a distributed network request to some other location, we get back that trace information or kind of that trace propagation across the network and can export it to that OTLP URL. So we already have tracing support. And for 1.0, what's really important for us is for wasmCloud to be completely observable. So if you're running it in a system where you have an OTLP collector for metrics, logs, and tracing or traces, we want to support that. Now, we've already kind of done the hard part, which is, setting up that exporter logic, and we've set up traces, which is, as far as I can tell, depending on how in depth you get with everything, one of the more complex parts. And we're already using tracing libraries to do our logging all throughout wasmCloud and the wasmCloud providers that we provide like first party. So logging is a little bit easier of a task, but what I wanted to leave some time to discuss is OpenTelemetry metrics, because metrics are ultimately what you would use if you're running wasmCloud in a dev, QA, or production environment and be able to answer questions about the system. Things like, and that's exactly the way that we're approaching the issue today. Things like, do I need to scale up my actor component? Or which actor components do I need to scale up? Or, am I saturating the resources on the specific node? Do I need to run an additional wasmCloud host on a different node? That one feels a little bit more system metrics, like you could kind of collect it from whatever orchestrator you're running on. Other really cool metrics that I think we can instrument to start with would be like a percentage of error rates for specific application or actor components, being able to track how many requests have succeeded or failed over a period of time, or even operationally at the host level. One that comes up pretty often is how many OCI downloads am I doing at one time? Because actor components are very small. They're WebAssembly components, so they're usually max in the couple megabytes range. but capability providers, depending on how many targets and everything you have, could be larger. So if you send 10 download requests to a host at one time, resources may spin up on that machine. It can take a little bit. So I wanted to, in lieu of actually having something complete to show you, leave a little bit of time during the call for just open brainstorming. If you've been running wasmCloud and you have some things that you would have loved metrics for to answer questions, I would love to hear your thoughts. It also doesn't need to be here on the call because I'm kind of springing this at the time. But just a general request for feedback over the next week or two as we implement this. If there's something that you wish you could have answered by looking at a metrics dashboard, please let us know. I will leave it kind of open-ended here. Does anybody have anything they'd like to add to the hotel metrics discussion? Sweet. Well, I look forward to having a little more discussion there once I can show you a little dashboard. Actor concurrency is one that I am really excited to be able to see, like handling concurrent requests over time, because now you have the ability to just have an unbounded level of concurrency. I want to see how many instances of a component are actually executing at one time because they're so stupid fast at returning requests. Okay, last section in the community call, I just want to do our regularly scheduled roadmap update with a specific call out. So if we look at the wasmCloud roadmap, I actually have not touched the work status page in a little while, and I took a look this morning. So I moved a couple of things over into the ready for work and specifically calling it out as a now work stage. But just a note that some things on this board may be a little bit out of date. I may talk to the maintainers and see if we want to decommission this one. As specified in the roadmap document that we publish, we really want to focus on like specific release milestones more than a now, next, later format. So we've made good progress. We've closed a couple more things since our last community call. Know that we closed this rename lattice prefix to lattice RFC, which was a really simple change, but something that can kind of clear up our naming a little bit. We've moved a couple things over to the in progress column because Victor has been taking on just basically improving our provider errors and separating them from actual application invocation errors, which would be really nice for application developers. When you call a capability provider and you get an error back, then that error is something that you can inspect for like application logic problems. And it just better matches the WIT interface that you are interacting with that provider over, which will come into play even more as we look at WRPC. Connor has been working on a couple of places in the wasmCloud org. So like in WADM, I know specifically to update the subscribers to use the event suffix topics. If you missed this change, we used to publish all of our events to one topic, but now we publish them to a topic that also includes the event name in the subject. So I use subject and topic interchangeably, but what's really nice about that is you could, for example, subscribe to all of the events for in a lattice for a specific event, like watch only host heartbeats, for example. Really helpful when debugging. Other than that, a couple of things have moved over to triage and ready for work. Notable in triage now is the WIT support for wasmCloud or WRPC RFC that we talked about. That's fun to say in the beginning of this call. And I just want to note that we have a couple things that are blocked here, but there are 1, 2, 3, 4, 5, 6 count them, 6 RFCs and features and tickets here in the blocked column that will be summarized and put together as a part of this componentizing links with WRPC RFC. A lot of thought has gone into creating that RFC, and I am pretty happy with taking a lot of the feedback from these tickets in the past where we've said, hey, we need a way to be able to run multiple versions of a single component at a time so that we can do things like zero downtime upgrades, A/B testing. We need things like actor to actor links so that we can, define configuration and define directionality on links. Another RFC here, per interface links is addressed by WRPC because you'll no longer be linking with a wasmCloud contract. You'll be linking based on the import and export inside of a component. So this blocked column is going to get a lot thinner over the next couple of days and weeks in favor of a somewhat larger but kind of encompassing RFC, which I think will just nudge us closer in the direction of 1.0, which is great. And as everyone knows, closing one ticket in favor of opening another ticket is the same thing as completing work, right? You finish the old one. It's closed now. So making great progress. Okay, folks, any questions on the roadmap or things that we need to add here? Yeah, Vance.
So it seems like pretty big changes. You still looking at Q1 for 1.0, huh? It seems ambitious.
It is ambitious. We're making a lot of changes, but that's not without lots of thought. And I think a key point of the changes here is, as currently planned, the existing workloads with like WebAssembly, like Smithy modules, we're planning on trying to leave that alone so that an existing module and existing provider can communicate the same way that they do today. One of the harder things about meeting a deadline like that would be, ripping all of that out and providing the right migration path and all of that. So, I can't argue. Go ahead.
Does the project have a policy around stability in terms of interfaces and migrations? The thing about distributed systems is that you expect that you're never going to have to lose your distributed system as you upgrade portions of it, right? And in my world, that these are sort of paramount things. Do we have like a policy?
Well, once we hit 1.0 for wasmCloud, the wasmCloud specific protocols were guaranteeing like strict Simber backwards compatibility. And so that means if it's too ambitious to do in the time frame and we can't guarantee that policy, then we can't call it 1.0. Now, when we talk about WIT interfaces, essentially the other half of the point of the way the component model works and the WIT definitions in terms of their versions is that once we cut WASI Preview 2, any additional version on top of that, whether it's Preview 3 or Preview 4, can be adapted to. So that's why we are making that a requirement for 1.0. We'll pin our WIT definitions to the 0.2 versions that come with WASI Preview 2. And then if you build with that, and then later on the Bytecode Alliance, the WebAssembly folks come up with WASI Preview 3. It includes new things and breaking changes to the old interfaces. We can adapt your older version of the interface to the newer version without you having to change.
I'm more concerned about hosts on the lattice. Like, do I have to have the entire lattice at the same version, or can I upgrade hosts on the lattice one by one to bring the whole lattice up?
Yeah, Taylor, I've seen you throw a hand up and then down and then up and then
Well,
down.
you answered
I'll let
it,
you
so I
jump in.
didn't really need to keep my hand up or anything. But I was going to say, so to answer specifically your question, Vance, there, that's what the 1.0 guarantee is going to be. We don't want to, anything will be, if we add new features, anything that we add cannot break anything that's currently running. So actually, the reason why there's so many of these big breaking changes coming up to 1.0 is because we have been trying to be good about backwards compatibility as much as possible, even though we're pre 1.0, specifically for the reasons you called out. We're working with distributed systems and people who need reliability. And so at this point, we're saying we are going to make a bunch of breaking changes on you, but then it will not break again until we get to a 2.0, which will be a little while. We're not going to go straight to 2.0 really quickly. It'll be a backwards compatible thing where you can then, if we go, when we release 1.1, you can roll out a 1.1 host and it'll still work with all your other 1.0 hosts as you run through all of them and start updating them. So that guarantee is very important. And that's very important to me, having run big projects like Helm and stuff before. We took that very seriously. And those of us who have unfortunately lived the life of Kubernetes know the like, oh yeah, it's a minor version, but we broke all these things. I've been broken so many times. So I have a lot of sympathy here and do not want to cause the same problems for our users. And it's even worse than what Liam was saying with pet sets to stateful sets. It was that like underlying APIs change and would like break Crestlet. So like it was I don't want that to be a thing that everyone else has to deal with. So we're going to try to maintain the only reason we'd ever break in a minor version is a security thing. And that's rare. That's very, very rare. So I've had that happen once where we had to have a truly breaking change because of a security thing. So
Okay,
yeah,
great.
that's kind of
No 2.0. And then we're good.
yeah,
Well,
no, we're not
not
going to
a
go.
quarter
We're
two.
yeah, we're not going to go 2.0 and like in the next 6 months after. No, we're not going to do like what some projects have done, where it's like, oh, now we're on 2 and now we're on 3. We're not going to do that. We're going to do the more like be careful about how we roll forward.
Yes, I really love this topic, and I'm very glad that you brought it up. And I want to actually share how intentional a lot of this planning has been. That we had this conversation like a year ago to kind of build up to this point. And I'm gonna share a little slide, although the team always is like, "Oh God, Liam and his slides." Like I can see everybody's like giggling now. Let's see if they hate me or not. They give me feedback on it later. So when we were thinking about the build up towards adopting WIT and adopting, moving wasmCloud to wasmTime, there was this real effort to make sure that wasmCloud was not just a line, but a leader in standards development. So that sort of forward iteration there, you've obviously seen over the last year, and when WASI point 2 moved forward, it gets adopted. I think in tomorrow's meeting it should pass. The JCO implementation was finished yesterday, which is the second implementation of the component model. So WASI point 2 should hit stable as of tomorrow here. So we've really been lining up to this point. Now that is absolutely aligned to the roadmap that we're planning for WASI for the year. And I say we, the big we, like the broader WebAssembly community. And next week we move into planning at the Plumbers Summit for recognized contributor and Bytecode Alliance members, where we're going to be doing the actual detailed planning for 2024, where we sort of line up the rest of these particular pieces here and what we're putting on the schedule. Now, the way we're going to be able to keep those commitments is our goal with what we've been planning through, and what we've communicated through WASI point 2 is all of our additions have planned backwards compatibility and are adaptable. And wasmCloud will obviously inherit those benefits with this new adapting. That's the first piece. So I really hope that you see how much intentionality has gone into that. Now, the call out on the ambitiousness of what we're doing with wasmCloud in WRPC, it has been also underway for a long time. And while there is definitely some scope here that's happening on the wasmCloud NAT side, has been an even I would say one of the biggest pieces of this work is already completed, and there were some key commitments that were landed in WASM time itself here that are already on main. So we've already made big strides in getting WRPC complete and across the line. So that work has been underway. Roman and Bailey have been working on that with many of the other WASM time developers for quite some time. So as a team, we've been really working towards this native WIT over a transport for quite some time in order to get that out there. And now this is part of our rollout strategy and implementation to get it done. And to then finally, just the final third point is, this is why we as a community have really held on the 1.0 is we were waiting for, never felt that we could declare a real 1.0 until we felt like WebAssembly components had landed, and WebAssembly components don't land officially until tomorrow. With 0.2, we don't hit stable. So, there's been a lot of people out there that make wild claims about where things are or how ready they are. We've been really focused on communicating, I think, transparently with the community so that we can make these kinds of commitments going forward. And I really would love to continue the discussion. You always raise, I think, like, you never shy away from asking hard and real questions. And I know we're close to time or at time here. I'll hand it back to Brooks, and maybe we can continue this one on Slack in particular. And my team can give me feedback later about my sharing of slides on the call.
Thank you. And I will.
All right, folks. Well, I think that seems like a pretty nice place to wrap it up. I don't have all of the links and all of the things that we normally do, but just really looking forward to the WASM.io and KubeCon in Europe / KubeCon EU WASM Day EU here in a couple of months at the end of, or in the middle of March. So looking forward to that. We'll keep doing callouts as we get closer and closer to those. I think we'll have a couple of talks to celebrate and all of those things. So looking forward to that. And otherwise, I think we will just see you all next week. Look forward to talking more in chat or in Slack about these things. And all right, let's get back to work.